Okay, Manish, away you go.
Yeah. So, hello everybody. Today I'm going to present the major boot driver, especially the refactoring work what we have done in last few months, and uh, some ideas regarding the critical data measurement design. And I will let you know what are the critical data and the patches for that purpose. Yeah. So with that, let me go ahead. So the agenda is we will first see the what was the previous state of the major boot driver and what exactly the refactoring work we have done for the major boot driver. Uh, the various gaps, whatever we have seen in the major boot driver, and the critical critical data measurement is one of the gap, and what are the patches we have developed for that purpose. So we'll discuss about it briefly. Uh, So if you see the previous status of the major boot driver, which was very much tightly coupled with the event log backend driver. So basically, the major boot driver was using the only the event log mechanism in order to record the measurement, and that the solution was not that scalable. So we thought that is a gap, and we need to refactor the measure put accordingly. And even we have seen the measurement of BL2 and other device tree images, which are loaded by BL1. Uh, those recordings are not get done by BL1 itself. So BL1 do the hash calculation of BL2 and pass that measurement to BL2, and then BL2 used to record that measurement in the event log. So we thought better bring in the whole major boot driver in BL1 and let the BL1 do that job. So again, we have refactor the driver so that we can easily port the major boot inside the BL1. And we have seen the event log driver is doing some platform work uh, by calling some platform function. So we thought there is opportunity to make this event log driver kind of self-contained. I know it is not always possible sometimes, like to make the driver is self-contained, but we thought here is the opportunity, and we made that driver as event means self-contained driver. So the refactored work, what happened right now, it gives the opportunity to add the multiple backends. Not only the event log backend, people can use their own backend driver, and means platform can use their own backend drivers and port it and use it accordingly. So code is structured in that way. And we moved the image measurement into the quite generic layer. So now it is just after loading and authentication of the images, we do the measurement. So there is no extra work. Yeah, definitely the platform hooks are there, that hooks need to be developed by the platform, but there is no extra work apart from that need to be done by the platform to do the measurement explicitly, which was before like that. We generally do the measurement in the BL2 post load functions. That is now removed. And as I mentioned, yeah. Can you guys? Okay, let me go ahead. So we are doing the recording of the measurement of the uh, uh, in BL1 itself now. So we have full-fledged major boot driver reported in BL1, and we have that capability in BL1 itself now. So specific to event log, it is BL1 basically initialize the event log buffer now and pass that event log buffer to BL2, and then BL2 will go on and extend that buffer with its own measurements. What are the images loaded by BL2? their measurements are get appended to this event log buffer. And as I mentioned, like, yeah, we made this driver as a self-contained driver. Now, event log driver, we removed all the platform hooks from the event log driver, and now it can be easily portable across. So all the patches are merged right now. And if you want to see the how the event log looks like, so it is almost the same how it was before, but on top of that, now it is loading the firmware config, means it is measuring the firmware config. This is done by BL1 itself, and TB firmware config and the BL2 image. So these all measurements are done by BL1 itself, and event log buffer get appended accordingly. So these are the console logs actually.
So Manish, I have a quick question, if that's okay.
Yeah, sure.
So when you say so it's good. What I see here is good, but I want to understand. So you're talking about backend drivers, right? So by backend, do you mean whether it's a physical TPM or something else?
Yeah, correct.
It sounds like okay, and it sounds like the event log driver also can be a backend. Is that correct, or is that changed now?
Yeah. So you can have multiple backend at a time also. Means you can push a measurement in physical TPM as well as event log also. So that is possible with this new mechanism.
Okay, can I do push measurements to a physical TPM and to event log? Because in my mind, yeah, writing measurements to some, I don't know, PCR or physical TPM or even firmware TPM is separate from what the event log does, right? So event log does not necessarily need to be a backend to the measured boot driver, right?
Yeah, correct. Means it is just like we have that provision in the FVP as of now. But yeah, I agree. Like if there is a physical TPM, uh, event log also can be one of, means they can push the measurement to the event log as well as to the physical TPM, and event log can be used for the verification purpose. So,
Okay, so that is possible with the refactor.
yeah,
right?
correct. Yeah, that is possible.
Okay, thank you.
So just to answer your question, Raghu, yeah, so here we have developed some platform APIs like this one, BL1, this is BL1 or BL2 plat mboot init. So you can initialize any backends over here. Currently, we are initializing the event log that is get initialized quite early in BL1 in FVP case, and then we can measure the image using this plat mboot measure image. So this is like again one who platform can implement their own method to how to measure the image and records its measurement either into the event log, or you can put it those measurement in both event log and physical TPM. So that is still possible. And then there is a tear down function like BLX plat mboot finish, where you can close all the backends. And if you want to give the information about that event log buffer, then that is also possible. We can give that information via device tree or any other platform specific method. What your platform wish, they can send that address to the next bootloader component. So this plat mboot measure image is getting called currently into the generic layer, but platform function has to implement this method on their own.
Okay, so if I were to implement the scheme that we talked about, right, where you have physical TPM and event log, then within plat mboot measure image, I would call the independent event log driver, and then I would call my independent physical TPM driver. Is that how? Okay. Okay, thanks.
So yeah, so this is what the work we have done till now, and we thought there is a still few gaps are there, that event log driver is directly using the embed TLS crypto engine. So this crypto it is possible, like some other crypto engine also we can hook it to the major boot driver in future, and we should not very much rely on embed TLS crypto engine that is today the case. So the patches for that purposes are in the review right now. Yeah, I will appreciate if some guys can have a look into it and provide their opinion on the patch. So it is just like removing this hardening in the event log driver, that it is always using the embed TLS. And we handle the error handling in the major boot driver. So previously it was not platform defined behavior, but now it is completely up to the platform how to handle those major boot driver related error. So FVP for now, it is always if they get the error, then if FVP gets any major boot error, it always panic. But it is always to the platform if they want to use any alternate methodology and then push the measurement, they can still do it in their own way. So that is I can say gap, because means currently we are always using panic. There is no new method we are developed over here, like to push the measurement to any alternate available mechanism. And we are not measuring the critical data as of now. So critical data measurement is one of the things that is missing currently in the major boot driver. So let's go ahead with that. Just I will show you what are my actually takes on the critical data measurements. So basically, what is the critical data? So critical data is that helps to maintain the security posture of during the boot and runtime. So mainly we think about configuration settings, security policies, and debug settings. This can come under the critical data. And the data that mainly the influence the boot flow behavior of the software. So generally, any configuration changes may alter the boot flow, that can come under the critical data. So what different types, this is just all understanding, it is not exactly written like this anywhere. So this is just like what we discussed internally in our team and come up with some kind of types and critical data. But yeah, I appreciate if anybody have opinion, just pitch in and give their ideas about it. So we think like there are two types of critical data. One is static critical data, that is the data that is always present in the non-volatile storage and software only consumed and no modifications. That is quite obvious. And at every boot, the value of this data remains unchanged, and there is and measuring of this data at any point in the boot flow is possible. So these are three things we think like comes under static critical data. And dynamic critical data, we think there are again two types. One is deterministic and non-deterministic. So deterministic data, it is like the data which is getting changed into the valid range, and but to some fixed value always. And non-deterministic, like we can't expect its value. It is always depend upon some hardware response. So we are reading some register and all and then getting the value, but that is a critical one. So that comes under non-deterministic. So it is very difficult to know what exactly the value of it. And this data should get measured after update, but before consumption. So mainly what I want to mention over here, like if particular data gets updated, then only so if BL1 does the hardware probing and updates some critical data in device tree, that BL2 is going to consume it. So it makes sense to BL2 measure that data. But BL1 update that global data and consumed by BL1 itself, then yeah, BL1 can do just after update. So basically only after update measure that data. and what kind of data we should measure. So we
Sorry, can you go back to the last slide?
yeah.
Apologize. So are you saying that, I'm not sure I agree with the data must get measured after the update and before the consumption, right? I mean, in reality, you could do, you could measure both, right? Before what it was before and what it was after, before update and after update, right? Of course, but it always has to be before consumption.
Okay.
I don't know that the rule must say this data must get measured after the update. You can do both, and I think that might be valuable in certain scenarios.
Okay, yeah, but what I thought, like, it is whoever is consuming, so over there it makes sense, like what is the value. So suppose BL2 is means BL2 is consuming always up, means after update only it get consumed, then better measure it after update only. So before update I still didn't get. So
Before, so what you get from before update is it tells you what got loaded, right? If you've got a device tree that you're going to update, measuring that will tell you what got loaded. And then measuring it after update tells you, okay, what exactly changed, right? So there might be value in having both those details.
This may help in the deterministic type of data where you for the deterministic case it makes sense that you check 2 times before updating it, compare it with what you updated, and then
it can help even in non-deterministic data, right? I mean, unless it's a hash, I guess that's okay. But if you're measuring raw data, right? If it's a raw bit stream or a raw value that goes as a measurement, yeah, it can serve debug purposes, right? Even for non-deterministic dynamic data.
Yeah, even I think it's valid to measure before and measure it after. Yeah, it does make sense. If the verifier has to know what was loaded before the update, and then if it has no idea what the non-deterministic value is going to be updated, it's always useful to know what was the original configuration loaded. Yeah, I think it does make sense to do both. If it's, I think the problem here is what is the, can we define one way to do it, or is it left to the platform to decide what they would like to measure, and maybe it's up between the platform and the verifier what all data needs to be measured at what points.
Right. Yeah, I would expect that to be fairly platform specific. Some things might be standard, but yeah, a lot of it might be platform specific.
Yeah. Okay, so I've taken that point. Yeah, maybe we'll think about it. Yeah, so what kind of data we think we should measure is like that the data which is influencing boot flow behavior, as I mentioned earlier, which comes as configuration settings, debug settings, security policies. So this data is very much should be in the valid state to maintain the security posture. So we thought deterministic data, we should measure it before update, as means this is little bit this one I have mentioned it mainly for the non-deterministic data. We should do it after update, but I agree, like, yeah, if we follow the same thing for everybody, like before update and after update, yeah, we can do that measurement. That is still possible. And the only thing what I not clear, like we are not sure about the undeterministic data because it is not giving any valid range or anything. It is completely depend upon the hardware response. So does it make sense to put that value in the different PCR altogether? So all dynamic kind of data which values are non-deterministic, so those values go into the different PCR and can be verified separately.
Yeah, so where we have found use for it is or at least right now, what we're thinking is it'll help with debugging, right? Even undeterministic data. So PCR is one of the backends, right? If you've got TPM, but there are other backends that you can have, like SPDM or something, right? And they've got, similar to PCRs, they have measurement blocks, and you can put raw values in there that can help you, through the protocol or through attestation, you get these undeterministic values that can potentially be used for debugging as well, right? Things like, okay, how many soft reboots have occurred, for example, right? Those could be useful for debug.
But those are not kind of critical data, we can say, right? Like, means I am not sure. Means reboot can be, means the example what you gave, kind of. Yeah, we can put that data, but that should go through this framework, or it can be tracked separately.
I guess the framework should not make the determination of whether some particular data is critical or not critical, right? I think that would be platform.
Yeah, that is completely platform, but that okay. People can add whatever they want. That
right.
is always there, but I'm thinking basically the definition of critical data mentions, like, yeah, it should it means it should be in the like after updating that particular data, the security should not be violated. Yeah, so that is the main thing. But yeah,
right.
I agree, like anything can be added over here. It is not up to the, it is not enforced.
Yeah. And an example of critical data that can potentially change would be, I don't know, if you've got like a trust zone controller, for example, and somebody says, okay, we want to measure what the memory regions are currently, right? And then after some point in time, it changes, because you allow dynamic update of those protected regions, right? Maybe there are a list of five valid configurations, over the lifetime of a boot, and it might be useful to get that in attestation, right? And that sort of falls between critical and dynamic and undeterministic.
Yeah. Okay. Yeah, I think I agree. So yeah, means and with this particular framework, currently we are not measuring the certificates. So we thought certificate does not have any particular data as such, like it only contains the hash values, and anyways the certificates are getting authenticated into the authentication flow. So there is no need to measure it explicitly in a certificate. Yeah.
So again, yeah, sorry. Again, comment here. So measured boot and secure boot, at least in my view, should be independent and separately doable, right? Someone might choose to not enable secure boot because secure boot enforces policy, right? If you fail authentication, you pretty much die during boot. But there are use cases where people are like, okay, even if you fail secure boot, I want to continue booting. I won't prevent an attack, but I want to detect an attack, right, via attestation. So in that case, measuring the certificates, will be useful, right?
But I think our framework, what we have today, is like major boot is always depend upon the authenticated boot, right? So, and that's how we discussed it previously. I think.
Yeah, but I think that dependency needs to be removed, right? Because they're really independent features, especially with the measurement framework going into BL1/bootron, right, into CRTM. I think that dependency is potentially artificial at this point.
Just a question about what you said, Raghu, that some platforms might choose to continue booting even if secure boot failed. Doesn't that go against the essence of secure boot? Why would you enable secure boot in the first place if you are able to just bypass it?
It's defense in depth, right? If one fails, you still have the other, for example. Right? That's why you have both. And at least at scale, people don't want scale, like cloud scale, people don't want bricks, because there was a bit flip or something like that, right? So they want to detect those bit flips, and so that they have more powerful environments to recover the system.
Okay, yeah, I see. I think we were under the assumption, that an authentication failure would lead to would be a fatal error, and so that's why we thought that if you've got secure boot enabled, then any error in the certificate would lead to a fatal error, and so you don't need to measure the certificates because you'll never propagate the measurement anyway. You won't reach this point. Or the other scenario would be you don't have trusted boot, you've only got measured boot. But in this case, if you've got no trusted boot, you've got no certificate, so you've got nothing to measure there.
There is no certificate in that case, so I don't think, yes, in non-authenticated flow, we don't need certificate, right?
So,
but
okay.
I think we had not taken into account, the use case you just described.
Yeah, so in the latter case, right, where you don't have secure boot and you have measured boot, I wouldn't, maybe I think my confusion is that you said that there are no certificates, right? But the newer devices seem to have identity certificates and things like that, right? If you implement DICE or those kind of standards, right? So maybe certificates is too broad a brush on this particular slide. Maybe you want to say the secure boot certificates.
Yeah, maybe I can say secure boot certificate really means I know there are other certificates which are not really taking part in authentication flow or having some critical information as you mentioned. So maybe that can be measured, and that can be measured as a part of image measurement itself and not as a part of critical data again. Yeah. Is that correct?
Yeah.
Okay, so to go ahead, we found out these many kind of data which are currently floating in our firmware, like the accepted flag in firmware update metadata is kind of dynamic, like it gets updated from the update agent, and there is a platform NV counter that most platform are using definitely, and the firmware bank index, firmware static dynamic configuration, security policies. Security policies I have seen sometimes like these are registers and values are present. So sometimes people can make a image out of it, and that image can be measured as a part of image measurement itself and not over here. But if somebody want to measure it explicitly, the secure policy only for few registers, they can still do it as a part of critical data measurement. And then there are debug setting parameters, like some parameters that enables the debug channels also. So we think like that is a critical. So this is only the guidelines I can say, but it is up to the platform. They can add any number of critical data. The framework is not actually enforcing anything over here. And we are not thinking to add any generalization over here. Like, this is the data we must measure or like that. It is completely up to the platform. They can form the data. So my next slide is like this. So they can form the critical data structure by their own platform defined critical data structure, and they can add the members in that data structure, like which data they want to measure, and then just update those members with the boot flow. And just before jumping to BL31, measure that critical data and record its measurement in any all available backends. And I'm assuming like that there is no runtime critical data measurement support is needed as of now. So it is like once BL2 jumps to BL31, it means like all the critical data measurement has been done, and there is no in runtime we don't have to do any measurement of the critical data. So this is what the output look like. This is what the PCR index I just won. It is where the critical data is actually getting measured in PCR1. So for this also the patches already in place. I tried these things with the FVP model and just tried to measure the only one single critical data with that. Yeah, but there are the platform functions are there. People can use that kind of platform function and measure the critical data by making the structures. Yeah, that's all I have. Any questions?
So Manish, just a clarification on Raghu's previous point. Is the current implementation of measured boot coupled tightly with authenticated boot? Can we not enable it separately without authenticated boot?
Yeah, it is like that right now, but yeah, we can remove that coupling if we think that is the way to go ahead.
I think right now the code itself, there's not too much dependency between the two systems. For example, there is no reusing of hash from the trusted boot to the measured boot or stuff like that. So there's no strong coupling. The main, if we wanted to decouple the two, then the bulk of the work, I think, would be just in the build system, in fact. Making sure that we can use both options independently, and maybe, making sure in the code that we don't have the guards. I mean, some code is not under just one guard under the trusted boot or measured boot guard, just because we thought the one would always be with the other. But I don't think it would be a lot of work. There's also just probably we've got to make sure that we pull in the right algorithms from embed TLS, just in case we use different hash algorithms for trusted boot and for measured boot. So, but mainly I think it's just just
build system related changes. Yeah, I agree.
Okay, thanks.
Yeah, I think that will be super useful to have if we can decouple that.
Yeah.
Hey Manish, Varun here. So one question about the embed TLS. Is it also integrated into the solution? For example, if I want to use something else, or let's say a hardware accelerator, is it possible today?
Yeah, so for that purpose, this patch is in progress. So we have only embed TLS right now. So we have decoupled, means a partner can add their own crypto engine now with this particular method. So yeah, it is possible. You can just avoid the embed TLS and go ahead with your another crypto engine.
Okay,
in
and
fact,
that is.
Sorry.
I just wanted to confirm that is behind platform wrappers, or I mean, if I have to do that, are there platform wrappers available, or I have to use a different mechanism?
Basically, you need to add some hooks for the crypto in crypto library. So there are some calculate hash kind of some function pointers are there. I think you need to populate for whatever the crypto engine you are planning to use, right? So you have to add the method over there, and even that particular hook you have to insert. But yeah, I think the code changes will be minimal there. Just like it will be calling that function pointer. So instead of getting embed TLS calculate hash function get called, it will call your another crypto engine's hash function.
Yeah, it's not a set of platform hooks per se that you need to re-implement. It's a whole, like Manish said, the whole crypto library glue, but it's not a lot. Like Manish said, it's just I think four hooks to calculate a hash, do a signature, for basic building blocks like that. And if you want to have an example of an alternate hardware-based implementation, I think we've got the crypto cell backend, which is used on some ARM platforms in the upstream code. So that could give you an idea of how to implement that for another crypto hardware accelerator.
Yeah, I prefer, yeah, guys, please have a look into this patch so it will be more clear then again. Yeah. Any other question? Okay, that's all.
Varun, sorry.
Yeah.
Varun, I've just put in the chat the link to the crypto cell code, where you can see that it's implementing this verify signature hook and verify hash, and what I've just mentioned, if you want to have a look at that offline.
Yeah, thanks, Sandrine. I'll take a look.
Hi guys, so is there nothing else you've got Manish to talk about in this space?
No, thanks. Thank you, guys.
So thank you. I don't have anything else on the agenda to talk about today. So unless there's any other follow-up comments on anything, I'll exit the call and make the recording and the slides available on the normal place. I'm a little bit behind there, guys. I do have 2 sessions I haven't uploaded yet, but now we've done Manish's one. I'll ensure that's done in the next few days. This is probably the last one, I suspect, this year, because I think we'll be running into Christmas, but I'll check with the team to see if there's anything else. Otherwise, we'll probably meet again in January. As always, if anybody in the community have got anything they want to present and talk about, feel free to reach out and we can schedule a session. We've been doing these tech forums for quite a while now, but there's only so many topics we've covered, and always looking for interesting areas to discuss. All right, if there's nothing else, I'll leave you all and speak to you all the next time.
All right, thanks all. Bye.
Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Bye. Thanks.